Welcome back. Today we're going to be talking about independent and dependent events. Our content objective is students will be able to find the probability with compound events. The language objective is students will be able to describe the difference between an independent and a dependent event. Why am I learning this? Well, it's important for real-world examples like finding the probability of selecting a specific type of granola bar from a box. So background knowledge, what happens when you want to find the probability of more than one thing at once? That's called a compound event. It's basically the probability of two or more things happening at once. And when we're trying to find the sample space of a compound event, what we want to use is either tables, lists, or some sort of tree diagram to help figure that out. So, some background knowledge. Sam and Joe are playing a game of rock, paper, scissors. What's the probability that at least one person will show rock? So what you're going to want to do is create a list, a table, or a tree diagram. I'm just going to show you a quick tree diagram. Sam could do rock, paper, scissors, and then Joe could do any of those options as well. So rock, paper, scissors, rock, paper, scissors, rock, paper, scissors. So since the question is, what's the probability that at least one person will show rock? Here's a quick table. Then we're looking for any sample space where rock is involved. So here are the lists that will work. Here in the table you can see a little bit clearer, like, oh, these are the options where rock was involved. Okay, so the key thing to remember is you want to use some sort of visual, a tree diagram, a table, a list. So here the probability would be 5 out of 9. Why? Because there's 5 options that have rock with a total of 9 different possibilities. So it's 5 out of 9, and since it's already reduced, that is our final answer. So now let's take a look at an example here. A bag consists of 3 reds, 4 whites, and 2 blue marbles. Find the probability of the following if the marbles are replaced after each draw. So here, you imagine taking the probability of red. Right now, there's 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would say 3 out of 9. So we take out a red, but guess what? We're replacing it, so which means we're putting it back into the bag. So what's the probability of red? Well, it's still going to be 3 out of a total of 9. Now, I am going to want to reduce this. Reducing is very helpful because it shrinks your numbers, and it makes reducing fractions a lot easier. So I'm going to reduce 3/9 into 1/3 for this fraction here and this fraction. Now I'm just going to simply multiply these two events, and my answer is going to be 1/9. So this here is called a dependent variable because since it's being replaced, okay, it's not changing the total amount. So now let's take another example, such as finding the probability of a white, then a blue, and then a blue. So white, there are 4 out of 9, so I'm going to write 4 out of 9. Blue is going to be 2 out of 9 still, because we're replacing, once we draw it, we're still replacing it back in. And then for blue again, it's still going to be 2 out of 9. Now I'm going to check if I can reduce any of these fractions. Unfortunately, I can't. I can't even cross reduce, so I'm just going to multiply straight across, leaving me with 16 over 729. So that seems like a bizarre number, but guess what? That is our answer. So now it says you roll a pair of dice called number cubes. What is the probability that you will roll the following pairs of numbers? So here, let's take a look at number 3. What's the probability of rolling a 4 and a 1? Well, here they are independent, so I'm just going to go ahead and say 4 is just 1 out of 6. Rolling a 1 is still just 1 out of 6. So that's going to get 1 over 36. Now, if you're wondering, why did I get 1 out of 6? There's only one way to roll a 4 out of 6 possibilities. Same thing for 1. There's only one way to roll a 1 out of 6 different possibilities. Multiply those two together, and I'm going to get 1 over 36. Okay, so now it's asking us, what's the probability of rolling a 3? Well, once again, there's only one way to roll a 3. It's going to be 1 out of 6. But what are the chances of me rolling a number that is even? Well, here it's not just one way. We can roll a 2. We can roll a 4. We can roll a 6. All of those are even numbers. So there's a total of 3 out of 6 possibilities. So I'm going to go ahead and multiply across, and it's going to be through, first of all, I'm going to reduce this fraction right here, which is going to give me 1/2. And so if you want, you can see it written as 1/6 times 1/2, and that's what's going to give you your 1/12 here. Okay, what's the probability of rolling a multiple of 4 and a 6? Well, multiples of 4 would include 4, 8, 12, etc. If you think about a number cube, the only multiple of 4 that shows up on a number cube is 4, so we're going to put 1 out of 6. And then a 6, well, there's only one way to roll a 6. That's also going to be 1 out of 6. I can't reduce any of these, so I'm just going to multiply straight across, leaving you with 1/36. Okay, so what about number 6? I want you to go ahead and pause the video and try this one by yourself. Okay, so for number 6, what's the probability of getting a prime number? Real quick, prime numbers include 2, 3, 4 doesn't work because that's composite, 5, 6 doesn't work because it's also composite, and that's it. So there's 3 numbers that are prime, so I'm going to go ahead and write 3 out of 6. Odd numbers are going to include 1, 3, and 5. So that's also going to be 3 out of 6. I'm going to go ahead and reduce those to 1/2 each. And 1/2 times 1/2 is going to give me 1/4. So my final answer is 1/4. So notice rolling a number cube both individually are independent. They do not depend on the other. There's nothing like replacements in comparison to the previous examples. Once you roll a dice, it doesn't depend on anything else. Okay, so now it says you roll a die, singular for dice, and then toss a nickel. Find the probability of each of the following. Okay, so what's the probability of rolling a 2? Well, there's only one way to roll a 2, so that's 1 out of 6. And what's the probability of getting heads for that nickel? Where there's 2 possibilities. You can get heads or tails. There's only one way to get heads, so that's going to be 1/2. I'm going to check if I can reduce or cross cancel. I can't, so I'm just going to multiply straight across, and that's going to be 1/12. I'm going to go ahead and try one more, and then have you try a couple on your own. Number 8, what's the probability of rolling an even number? Well, the even numbers are going to include 2, 4, and 6. That's 3 out of a total of 6, so I'm going to write 3/6. For tails, there's only one way to roll, flip a coin to get tails, so that's going to be 1 out of 2 possibility, heads and tails. I'm going to go ahead and reduce 3/6 to 1/2. 1/2 times 1/2 gives me a total of 1/4. Now, at this point, I'd like you to pause the video and try number 9 and 10 by yourself. Okay, so for number 9, the probability of rolling an odd number, you guessed it, it's 3 out of 6. The probability of getting heads is 1/2. If you reduce this fraction, you should get 1/2 times 1/2, which gives you 1/4. Number 10, the probability of getting a multiple of 3. Well, multiples of 3 will include 3 and 6. 9 included, but 9 does not, you can't find a 9 on a number cube, so I'm just going to stop at 6. So there's 2 out of 6 ways to get a multiple of 3. For heads or tails, well, it's any of them. So that's 2 out of 2, so that's certain. Whether you flip it, you're either going to get heads or tails. So this is going to reduce to 1/3. I can divide by 2, and here we can reduce that to just 1/1. So my answer is 1/3. So don't let this fool you. I know this was different, but think about it. What's the probability of you getting heads or tails? It's certain. You're going to get heads or you're going to get tails. So that's why it's 2 out of 2, which is 1, which we know as certain. So independent events is basically if the occurrence of one event doesn't affect the probability of another. So example, me flipping a coin and tossing a number cube, they did not depend on one another at all. Okay? But a dependent event is basically if the occurrence of one event does affect the probability of the other. And we're going to see some examples in the next few slides. So here, if a bag consists of 3 red, 4 white, and 2 blue marbles, find the probability of the following if the marbles are not replaced after each draw. So here is an example of a dependent variable. I'm sorry, a dependent probability. What's the probability of getting red? Well, I see 1, 2, 3 reds out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 out of 9. But since it's not being replaced, a red is being removed. So right now, notice there aren't 3 reds anymore. There's a total of only 2 reds. And in fact, it's not a total of 9 anymore either. There's a total of 1, 2, 3, 4, 5, 6, 7, 8. Which makes sense because it's 1 less since we did not replace the red marble. Unlike the previous examples, it was replaced, so we put it back. So that's why it continued to be out of 9. So now our new fraction is for the red is going to be 2 out of 8. Okay, which makes sense because there's 1 less red and there, of course, 1 less marble from the total in the bag. So now I'm just going to go ahead and check to see if I can reduce or cross cancel. 3 ninths is going to reduce to 1/3. 2 eighths is going to reduce to 1/4. So I'm going to multiply these two fractions and my answer is 1/12. So again, this is called a dependent variable because the second we took out a marble, the probability of red changed, right? Even the probability of white would change because it's no longer out of 9. It's going to be out of 8, etc. So now, let's take a look at another example. Here, what's the probability of getting white, blue, and then blue again? Well, here the probability of white is going to be 4 out of 9. But now 1 white is going to be removed. So now there's only 3, and which means there's only a total of 8 now instead of 9. The probability of getting blue is going to be 2 out of 8. So again, if you're wondering why there's 1 less, is because the white has been removed. You can even count. There's 1, 2, 3, 4, 5, 6, 7, 8. Only 8 left. So now let's take out a blue. If we take out a blue, now we're only going to end up with how many blues? Well, there's only 1 out of a total of 1, 2, 3, 4, 5, 6, 7. So what you're going to notice is, since we're not replacing, you're going to see the total amount decreasing every single time depending on how much we drew. In this case, we're drawing 1, so each time it loses 1 from the total. So now that we've got our 3 fractions, we're going to check if we can cross cancel because that's helpful, and we're also going to check if we can reduce. The only fraction that we can reduce is this number here. So we have 4 ninths times 1/4 times 1/7. So now, hopefully you see, look, the 4's can cross cancel, which is really nice. 4 divided by 4 is 1. 4 divided by 4 is 1, which is just going to leave me with 1/63. Now, this is great. Notice, because reducing makes things nice, cross-reducing makes numbers smaller. Now, if you didn't see this and you decided you're just going to multiply straight across, you would have had 8/504. And you would have to realize you can reduce both by 8 or by 2 and then keep going until you can't reduce anymore. And then you would get to 1/63. But notice, some of you may not notice that right away from this fraction. So it's best to cross-reduce or reduce right away. Okay, so now let's take a look at some more examples before I have you try some on your own. It says 3 girls and 2 boys volunteered to represent their class at a school assembly. The teacher selects one name and then another from a bag containing the 5 student names. So let's think for a second. Is this considered an independent probability or dependent probability? I think it's a dependent probability. Why? Because if a teacher selects the name, is it likely that the teacher's going to throw the name back in the bag and pick another one? The answer is no. The teacher's trying to select 2 different names. Once it's selected, they keep it out of the bag and select another one to choose a different student. So this is a dependent probability. So first, what's the probability of getting a girl and a girl? Well, we know there's 3 girls and 2 boys that volunteer to represent their class at the school assembly. The probability of getting a girl from the first would be 3 out of a total of 1, 2, 3, 4, 5. So 3 out of 5. Now that a girl has been chosen, one of them has been removed. So now it's going to be a total of 2 girls out of a total of 1, 2, 3, 4 different possibilities. Now here, that's going to be it. I'm going to check if I can reduce or cross cancel. I can definitely reduce this fraction here. So it's going to be 3/5 times 1/2, because I'm dividing both the numerator and denominator by 2, and that's going to give me a total of 3/10. Okay? Okay, let's take a look at another example. What if the probability was getting a boy first and then a girl? Well, first, the probability of getting a boy is going to be a 2 out of 1, 2, 3, 4, 5, so it's 2 out of 5. But considering that, there's one less boy now. And now, what's the probability of a girl? There's 3 girls out of a total of 1, 2, 3, 4. So you're going to notice that the it's no longer going to be out of 5. It changed to 4 in both cases because the name is not being replaced back into the bag. So here we're going to check if we can cross-reduce or just reduce our fractions. We can't reduce our fractions, but I notice we can cross-reduce. I can divide both of these numbers by 2. 2 divided by 2 is 1. 4 divided by 2 is 2, giving me a total of 3/10 as well. Okay, so now let's look at some examples for you to try out. Go ahead and pause the video and try 16, 17, and 18 by yourself. Okay, so let's go over our answers. It says you select a card at random from the word pre-algebra. Without replacing the card, that's a key word, without replacing the card, that means it's going to be a dependent probability. Every time you take a card out, you're changing the probability of the next letter being chosen. You select, let's go back. Without replacing the card, you select a second. Find the probability of selecting each set of letters. So here, what was the probability of getting an A? Well, probability of getting an A was 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 2 out of 10. But once an A is chosen, I'm just going to go ahead and eliminate this last one. It doesn't matter which one you eliminated. Not really, but just so that you know, I went ahead and took the last one out. What's the probability of getting a G? Now notice it's not going to be out of 10 anymore. It's going to be out of 9. You'll notice here 1, 2, 3, 4, 5, 6, 7, 8, 9. There's only 9 left. What's the probability of getting a G? Well, there's only 1 G. So that would be 1 over 9. Here, you're going to double check if you can reduce or cross-reduce. Here, we could reduce to 1/5 times 1/9, and your answer should be 1 over 45. Okay, next one. What's the probability of getting an E? Well, there's 2 E's, 2 out of a total of 10. R, there are 2 R's. But notice again, since one of the E's is going to be removed, let's go ahead and eliminate the first one this time. There's only going to be 2 out of 9 this time and not out of 10 anymore because one was taken out. So we're going to write 2 out of 9. I'm going to check if I can reduce. I can reduce this to 1/5 times 2/9. Can I cross reduce? The answer is no. So I'm going to multiply straight across and my answer is going to be 2 out of 45. Okay, now last but not least, what's the probability of getting a vowel? Vowels include, let's go, A, E, I, O, U. So how many vowels are there? There's 1, 2, 3, 4 different vowels out of 10 total letters. But now assuming one of the vowels are gone now, it's no longer out of 10, it's going to be out of 9. It says what's the probability of getting an L or a G? I only see 2 altogether, 1 L, 1 G, so that's going to be 2 out of 9. So the key thing to remember is when you're not replacing something, the denominator is always going to change. Typically, it decreases. So here I'm going to go ahead and reduce this by 2, so that's going to give me 2/5 times 2/9. I can't cross reduce, I'll multiply straight across, giving me 4 over 45. So that is your answer. Hopefully you got all of those right. If not, feel free to rewind back and see what your mistake was until you get it right. So guess what? That concludes the lesson for today. Thank you so much for tuning in. And as always, until next time, bye.